Welcome to our video, 8 Facts about Ice Melt in Greenland and Antarctica. In this presentation, we'll explore the critical role that ice loss in these polar regions plays in global sea level rise and climate change. From the intricate workings of Greenland's and Antarctica's ice sheets to the alarming acceleration of ice melt, we'll uncover the science behind these phenomena. Join us as we delve into the meltwater feedback loops, glacial flow, and the far-reaching impacts these changes have on our planet's climate. Let's get started. 1. Contribution to sea level rise. The ice sheets of Greenland and Antarctica play a pivotal role in global sea level changes. Together, these regions hold an immense volume of ice, enough to potentially raise sea levels by about 65 meters, 213 feet, if completely melted. This staggering statistic underscores the critical importance of monitoring ice melt in these areas. As the ice melts, it contributes to the rising sea levels, threatening coastal communities worldwide. The gradual rise in sea levels may seem minor, but over time, it can lead to significant changes in coastlines. This contributes to the risk of flooding in low-lying areas, making it a pressing concern for global policymakers and environmentalists alike. 2. Greenland's ice sheet. Greenland boasts the second-largest ice sheet in the world, a vast expanse that has been losing ice at an unprecedented rate. This ice sheet is responsible for adding approximately 0.7 millimeters to global sea levels each year. The accelerated ice loss from Greenland is alarming, primarily driven by rising temperatures and changing atmospheric patterns. As the ice sheet thins, it not only affects sea levels but also the ecosystems and wildlife dependent on it. The melting also impacts local communities, particularly indigenous peoples who have relied on stable ice conditions for centuries. The rapid changes in Greenland serve as a stark reminder of the broader environmental shifts occurring globally. 3. Antarctica's ice sheet. Antarctica holds the title for the largest ice mass on Earth, a continent of frozen wonder. However, not all of Antarctica is losing ice at the same rate. The West Antarctic ice sheet is particularly vulnerable, showing significant ice loss attributed to warming ocean waters. Conversely, parts of East Antarctica remain relatively stable, with some areas even gaining ice. This variation within Antarctica highlights the complex dynamics of climate change and its effects. Scientists continue to study the region to better understand the delicate balance between ice loss and gain. The stability of East Antarctica offers a small glimmer of hope, but the overarching trend remains one of concern. 4. Ice loss acceleration. The pace at which ice is disappearing from Greenland and Antarctica has seen a dramatic increase over the past few decades. In Greenland, the rate of ice loss has more than doubled since the 1990s, highlighting the urgency of the situation. This acceleration is driven by a combination of rising global temperatures and changes in atmospheric and oceanic conditions. The rapid melting contributes to rising sea levels and poses a threat to coastal habitats and human settlements. This trend of accelerating ice loss serves as a stark warning about the pressing nature of climate change. As the ice disappears faster than ever, the implications for the planet are profound and far-reaching. 5. Meltwater feedback loop. One of the most concerning aspects of ice melt is the meltwater feedback loop, a cycle that amplifies the warming process. As ice melts, it reveals darker surfaces beneath, such as ocean water or land, which absorb more sunlight. This accelerates warming and further melting, a phenomenon known as the albedo effect. This feedback loop creates a vicious cycle that contributes significantly to the overall ice loss. The more ice that melts, the more heat is absorbed, leading to even more melting. This cycle is a critical factor driving the rapid changes observed in the polar regions. Understanding and mitigating this loop is essential to slowing down ice melt and its global impacts. 6. Glacial flow. Melting ice doesn't just disappear, it has profound impacts on the movement of glaciers. When surface meltwater seeps down to the base of glaciers, it acts as a lubricant, causing them to slide more quickly into the ocean. This process contributes to sea level rise and can lead to increased calving, where chunks of ice break off into the sea. The speed at which glaciers flow into the ocean is a crucial factor in understanding sea level changes. As glaciers accelerate, they can destabilize the entire ice sheet, leading to further ice loss. This dynamic movement of glaciers is a critical area of study for scientists monitoring climate change. 7. Impact on global climate. The melting of ice sheets has far-reaching effects on global climate systems. One significant impact is on ocean circulation patterns, such as the Atlantic Meridional Overturning Circulation, AMOC. Changes in these patterns can alter weather systems, leading to more extreme climate events worldwide. The disruption of ocean currents affects temperature and precipitation patterns, influencing agriculture and water resources. The interconnected nature of Earth's systems means that changes in the polar regions can have global repercussions. As ice sheets melt, the cascading effects on climate and weather patterns become increasingly evident. Understanding these connections is vital for predicting future climate scenarios. 8. Potential thresholds. Scientists warn that there are critical temperature thresholds that, if crossed, could lead to irreversible ice sheet collapse in Greenland and Antarctica. Such a collapse would have dire consequences, committing the planet to long-term sea level rise. These thresholds are a focus of intense research, as understanding them is key to preventing catastrophic outcomes. Once crossed, the changes could be irreversible, with profound impacts on global coastlines and ecosystems. The potential for reaching these thresholds highlights the urgent need for action to mitigate climate change. The stakes are high, and the window for preventing irreversible damage is rapidly closing.